So, in the previous session, we have talked about the global warranty and good practice half. Now, the legal half, where a regulator can knock on the door, which is EN 18286. Now, if I'm talking about ISO 4201, it's about being a good organization. And what follow is about being a compliant one. Now, different motivation, but much sharper thing. So now, as you can see here, an image of a pyramid. So it illustrates a risk-based framework for regulating artificial intelligence. So this pyramid closely mirrors the regulatory structure of frameworks like the European Artificial Intelligence Act, which categorize AI system by the level of danger they pose to society and assigning a legal obligation accordingly. So if you can see here, we have a different tiers here. So we are starting with the prohibited uses, then we have a high risk uses, we have limited risk uses, and we have a minimal risk uses. So the first risk, which is at the very top of the pyramid, is a small red band representing AI application that pose an acceptable threat to safety or livelihoods or rights. So these systems are entirely banned. So there are different examples of prohibited uses. For example, social scoring systems or real-time biometric identification, which uses a mass facial recognition in public spaces, and subliminal manipulative techniques, for example, auditory clues or flashes, and so on. Second one we have it here is a high-risk uses, the orange tier, which represents AI system that negatively affect safety or fundamental rights, but are not outright banned. So, as the scale of justice on the right of the image illustrates, almost all the legal weight and regulatory compliance fall into this category. So, organization developing or deploying these face strict requirement for risk mitigation, data quality, logging, and human oversight. So, for example, AI in medical devices, or recruitment in HR, or critical infrastructure or law enforcement. So, which means they are tied to follow these legal weights and regulatory compliance. Now, the third one we have here is limited risk uses, which is a transparent duties. So, the yellow tier represents AI system where the risk is primarily related to a lack of transparency, and the legal obligation here are much lighter. Developer most just need to ensure users are aware they're interacting with the machine so they can make informed decisions. For example, chatbots or deepfakes or emotion recognition systems. So they lies into limited risk uses here. Now we have the base one, which is a minimal risk uses. So the broad green base of the pyramid represent the vast majority of AI systems currently in use, because these systems pose like to no risk to citizen rights or safety. They face minimal to zero legal frictions or regulatory requirements. For example, a spam filters or AI used in video games or business content recommendation algorithms. So just to give you a key takeaway here, the red arrow on the left shows that as you move up the pyramid, the legal risk increases. However, the true burden of the law is focused especially on the high risk orange tier, which must balance powerful societal integration with the high legal accountabilities here. So now what is high risk AI, which is a part of European Artificial Intelligence Act risk tiers, which we have discussed a few minutes before. Now we're looking at three examples. We have medical and safety device, we have employment and education, and we have a critical infrastructure. So medical and safety devices, they are more like a pacemakers or surgical robots or autonomous vehicles. So failure here is bodily. Now, critical infrastructure is a power grid, water, transit. So failure here is physical and public. Now, for employment and education, CV screening or worker monitoring or exam grading. So this is the one that catches people off guard. So we have to dwell on it. So recruitment tools feel like an HR convenience, not a safety critical system, but it decide access to a livelihood. And it does so at enormous scale. So one bias model rejects 100,000 people, where one bias interviewers rejects a few dozen. So scale is what makes it high risk. So high risk doesn't mean that artificial intelligence model is a bad or bad. It means that we always have to prove it's fit for purpose before we sell it, like a medical device, not like an application itself. So now we're looking at the EU AI Act, which is a law, not an engineering manual. So high-risk systems shall be designed so that natural person can effectively oversee their functionality, which is true, which is important, and completely unacceptable for our developers. So we are looking at how large should the button be, or what must be logged, who signs off. So that gap between law and build is where harmonize the standards. Now, EN 18286 is like a translation there, and it is for Article 17 from EU AI Act. So we are following it and we are trying to look at the defensible route to demonstrate to that we have met the legal obligation. And the term of art is presumption of conformity. Now, we are also looking at or focusing on evidence generation. So ISO 42001, it asks you to manage well. Whereas EN 18260, it asks you to prove you manage well to a market surveillance authority. It can be in documented form or it can be after certain years. So it's a difference between being a safe driver and having a dash cam. Both matters and only one helps you in a dispute. So as we are moving forward, the engineering priorities has been changed. We are logging, documenting, and we also have to look at the traceability. And those become being there to nice to have it, or it can become as a deliverables. So there are three key requirements of EN 18286: data governance, technical documentation, and automated logging. So when we talk about data governance, it rules on how trained data is collected, cleaned, and validated, and critically. So which is mainly about the provenance. So you must be able to look at every data set which it came from. So it's a supply chain and a nutrition label for the data. So if a good manufacturer can't tell you which farm the ingredients come from, they can't sell it. So it's the same principle, the uncomfortable consequences that we scrap it from the internet. It's not a provenance statement. Now, the technical documentation is like a standardized dossier, like an architecture or intended use, and it consists of our non-limitations, or we can say the accuracy matrices or test results. So it is written before the product reaches the market. So limitation means that formally publishing what your system is bad at, and it can be commercially awkward, but legally it is mandatory. Now we have automated logging. The system records events and errors across its lifetime automatically. So we can reconstruct it from the database if we try, which is automatic. And the purpose is traceability. So when something goes wrong 6 months in, you can answer what the system saw or what it decided and when. like an aircraft black box. So all three are far cheaper design in than retrofitted. So retrofitted logging or provenance into a live model is one of the most expensive forms of technical debt in this field. So when we talk about retrofitting logging, so it's like we are looking at if you're trying to add a new feature or a component or technology to a system after it has already been built and deployed. So retrofitting logging means that you're trying to attempt to bolt on tracking, record keeping, and audit rules to an AI system or software application long after the core architecture has been finished. So human oversight. So high risk AI cannot run fully autonomously. There must be a human who can understand it and intervene it. So we have override capabilities. A human operator must be able to disregard, override, or reverse the output. Note that understand is doing real work in that sentence, like an override button on a decision nobody can interpret is useless. And the interface has to surface why, not just what. Stop button in critical settings, a mechanism to halt the system safely immediately. So straight out of industry mechanism safety and that lineage is intentional. Now, combating the autonomous or automation bias. This is a subtle one, and the one I would spend most of the time on if I'm a developer, because automation bias is human tendency to overtrust a machine output. Given the navigation example, drivers who follow the set nav direction into a field, it piles the visible evidence, and they were wrong. So the machine sounded certain, so they stopped thinking. So you can satisfy every technical requirement. You can have override button, you can stop the button, and you can have a dashboard, and you can still fail because the human in loop rubber stamps everything. So 99 correct output trained our operator to approve the 100 without reading it. So the requirement is about training protocol, not just interfaces. So governance is partly a human factor problem, and that's the idea I would like you to consider whenever you are creating any AI model. So I just want you to think as well, like, have you ever clicked accept on something a system suggested without really clicking it or checking it? So if you are doing that, that's a failure move and it's not exotic.